This is a talk about tracing an application in Go, kind of like using strace on a system if you're a system admin that does that sort of thing. But I inherited a program that I needed to take care of, and I didn't understand it. I needed to figure out what it was doing. It sat there, it received messages, it had timers, it did things asynchronously, and I just wanted to see what order stuff was getting called. I could go in and add some printfs to the code to see what was going on, but I wasn't quite sure where. I wanted to add them everywhere, basically. Debuggers didn't work. Delve maybe could do something like this sometime. The new tracing framework probably can be twisted into doing this at some point, but I didn't see a good way to do it. So I wanted something like strace, and heck, writing Go using Go is fun. So where do you start? I knew about the Go parser, the Go AST, but I didn't know how to modify the AST. I could read it, I could check things, but I wasn't sure what to do. Luckily, we have a great way of generating an AST. It's called writing code, and then you can just parse it into the AST really easily. So for basic stuff, text.template works really well, and then you give it the Go format, and it will make it look nice at the same time. This is basically what I wanted to end up with. I'd have a function first or second, and I wanted to just print when it was called, print what it was being called with, and possibly even print when the function was done. So the process of generating this in the code was a matter of calling parser.parsefile. This is the Go parser library. That creates the AST. Use the AST to inspect method, inspect function to visit each node and determine whether we want to annotate it or not. And then we use our little template to generate the debugging code and the location where it is in the source. Then we can format that code back properly using the format.node function and go through the source of the file and take those edits that I saved with their locations and just insert them into the code. It didn't have to be formatted very well. It just had to be in the right point, because then we used format.source to reformat the code, and out we have a nice Go program with the annotations. The generated code looks something like this now. Everything has a double underscore just to sort of obfuscate it to prevent name collisions. If someone did that in their own code, we still might collide, but it's a start. This was a quick little project. This now also has a custom formatter and a unique ID for each function as it's called and exits. This is what the template looks like inside the trace code. It's a little bit hectic in there, but you can see that I just basically have some strings in the gotrace program that I format for each call as it goes through the source. I needed to make an internal log package in order to do this. I didn't want to have to go through the program that I'm annotating, determine whether they import the log package and modify their log package, or whether they import the fump package and modify and work around their import of the fump package. So I just made my own log package, and that gives me some benefits in that I can make a custom logger. I wanted something like the sharp V formatting for everything. But I found out when you have a large byte slice passed in and it gets hit with that sharp V, you get the full byte slice printed out. A little more than I wanted. And I also get a unique ID from the log function. Having the log function lets me use the log package lets me use that kind of as a singleton. I can just insert that into every single file. I don't have to worry about packages on a whole or what gets built together. I just import that log package and everything and use the package itself as the function. This here shows shows the running of the gotrace program. It runs on files right now. You should probably add a way to run it on packages, but you can just give it a list of files. It'll rewrite them in place, kind of like gofumpt or go imports. You can filter what functions or methods you're annotating. You can exclude them. You can exclude things that aren't exported. And this here gives us a little demo of the code. I'm going to run the code you see here. But what I have done previously is this command at the top here, gotrace, and from the Go source, net HTTP Go. So this here will show you every single function call that happens in the HTTP library when we call this get function twice. And here we can see every little thing that gets called. If I limited that to exported functions, it'd be significantly shorter, and you could get the overall gist of it. But maybe you're trying to find some internal state that was done here. The IDs show you where the function enters, and you can use that to correlate where it exits further down. If it called other things or was being run asynchronously, you can see. Like the return of these things down here. It's hard to see my cursor. And there's another one down here. You can see where like this number 98 net EOF reader didn't return until the next call of that get later on. And the whole run took 187 function calls within that package. And it also has rough timings for each of those calls. And it looks like we're about done if I have any questions.